To make our project more manageable and make it debugging friendly, we have to split the coding files into multiple smaller files. Here I will show you an example how that works in action and how to split the file so that we don't get any compatibility issue or errors. Firstly, we will have a main.asm file. This file is the backbone that will call other procedures or other files when necessary. Here for the example, I have chosen the editor feature editor. So this project of ours have 6 features and editor is one of them. It is actually text editor, but I will refer it to as simply the editor. To implement the editor feature, we need 2 files. This is file number 1, this is file number 2. You might have noticed that I have named the first file as editor_data and I have named the second file as editor_proc, that is procedure. If you notice that our main file has stack, it has data segment, stack segment and code segment. There is a main procedure and the main procedure ends. In between there will be many codes. Just imagine there are some codes. Now we want the editor codes to be imported into the main code. This editor features code will not be written inside the main assembly code at all. Instead, we will split up the editor, put some of the information in editor_data, put some of the information in editor_procedure. So these split up files needed to be imported into the main file. We will import these _data files below the data segment right here. We will include editor_data. I just added this line here because this file will contain data, hence I am importing this specific file under the data segment. If I were to, for some reason, import this file, say here, I did include inside this main proc, I did include editor_data, our program will crash because variables have to be defined under the data segment. So we can't import the data inside the code segment. It has to be inside the data segment. So what would be inside this editor_data file actually? It would be simply a collection of variables. Say I want a variable called variable1. I want the size to be byte, so I wrote define byte. Then maybe that variable is unknown, okay, it can stay unknown. I want a new variable called Fahim. Maybe it is a word, it can have a text inside it. So when we write include editor data, what happens is the entire code from here gets pasted into here when the code gets compiled. So we get the flexibility of writing the code separately, having a less cluttered interface, and the code still gets assembled properly and it will run. Now Inside the editor.proc, as the name suggests, we will define procedures. Say I write a editor named procedure. Because it is a procedure, so I write procedure. It's just a way to define a procedure. Then there are some codes in here, and I end that editor. This second file has to be imported below the code segment where the main procedure ends. It has to be below it. So I will write this: include editor underscore proc. Notice that this has been imported here after the main procedure has ended. Below the main procedures line, I included the procedure code for the editor. I can also include other procedure files. Say we have a calculator, so it may be a cal underscore procedure. Maybe we have a checksum, so we will write a checksum underscore proc. What these include lines are doing is it's copying the entire code, then placing below the endp main. Under this endp main, the entire code will get pasted during the compilation. We don't have to paste anything here. We will write our code separately inside this editor underscore proc.asm, and we will import or include the files under the endp of main, which is located in the code segment. Now for these two files, the example looks fairly easy, but if we consider that we have 6 features, they will have multiple lines of codes. Each will have complex logics and procedure calls. If we do not split up the files, the main file will get very bulky and it will be harder to debug. So our 6 files initially will become 12 files, and there will be some additional files, some additional procedures that are required for the project to give the illusion of being an operating system. All these files have to reside in the same level. Let me show you what I mean. In our project repository, we have a folder. Our repository's name is this, dumbos. So this folder right here contains src folder. This is a folder, and inside this folder we have, right now this is mostly empty, but we will have these files: main.asm. Under the same source folder we will have editor underscore data.asm. we will have editor underscore procedure.asm. we will have calculator underscore data.asm. we will have calculator underscore procedure.asm. Why am I putting data and procedure with the name? So that it is easy for us to distinguish between the data file and the procedure file. Hence I am writing the name in these cases. Now these all files, when they reside into the same level, we'll know each other when we import them here. But if some file is outside the source folder, then we would need to use absolute path, but we don't need to increase the complexity here. We can keep all the files into the same level and use the relative path method, which is simply using include and the file name next to it. This is the file name and this is the include statement. Then there is the file name editor underscore proc. This is the relative import method and it will work just fine. Did you notice that inside the editor underscore data there is no stack, there is no dot data segment, there is no dot code segment. Even if inside the procedure file editor underscore procedure there is no code segment, there is no data segment, they don't exist here. This is because the stack, the data and the code segment, they will be fixed for our single program, and our program is this main.asm, and this program will define inside our memory or RAM which portion would be the code segment, which portion would be the data segment, which portion would be the stack segment. This would be defined by our main.assembly. So no other files should declare its own code segment, its own data segment. Should not declare. They will be imported inside their respective segments and they will be called inside the main procedure when needed. If you need to use the editor procedure that we have defined here, you will simply write or call the editor inside your main proc. Notice this is our main proc, it ends here, and inside the main procedure I just called the editor. This is the name for our this procedure. The editor procedure will have the logics to simulate the text editor feature we have for our project. I hope this explains the vision or the boilerplate for our coding project that we are going to achieve through assembly coding. The import statements here are different compared to Python, compared to C. It's because those are more or less higher level language and they work like importing libraries and they can reference other files on a higher level abstract. But as assembly is very low level code, we have to be mindful here about where we import the file and exactly what portion of a file we are importing.